Hello and welcome back. Alright, so in our last video we implemented a very crude linked list. The main problems were that we had to do all of the maintenance ourselves. So this is pretty bad programming practice. One, as it requires the coder that's going to be using our node, our linked list, data type that we're creating to manage far too many details. We have to update the next pointers on the nodes, and we have to keep track of each individual node ourselves, and that's just kind of a mess. So let's go ahead and jump back over into our whiteboard and talk about how we can fix this problem. So we know that we're going to need some node in our lists, but it's conceptually possible to have an empty list. So what we're going to need is we're actually going to need another data type. And we're going to call this data type list. And inside this list, we're going to have a node pointer called head, which will point to the first item in our list. So if our list is empty, it will point to null. And if it's not empty, it will point to the first node structure. Okay, let's go ahead and jump over into Xcode and create this type. Alright, so right beneath node, I'm going to go ahead and create a struct list, and it's going to have a node pointer called head. Okay, now based on our whiteboard picture, we already know that that head is going to need some special implementation the first time we create a list. So let's go ahead and create a function called create that creates a list for us. Okay, so what we want to do is we want to return a new list. And we're going to create, well, let's actually go ahead and call it void. And we'll do this in two parts. We'll say list init, and we will pass in a list pointer. Okay, so we know that the very first thing we want to do is we want to check to see if list is null. If it is, just go ahead and return. Otherwise, we want to set the list head pointer equal to null. Okay, so then back down into our main function, what we're going to do is at the top of it, we're going to create a new list, and we're going to call this list. And now we're going to have to call the list init method and pass in the address of the list. And I'm going to go ahead and comment out this block of code. And so I hit command / to auto comment all that out. Okay. Let's go ahead and comment out the print list function too. Alright, perfect. So what that has done now is we have created a function to essentially initialize our list correctly. So the first time we create a list, we then need to call this init method, which will null out head. So our list now, our list, that looks like a G. Our list has a head pointer, which is null. Perfect. There are better ways to do this initialization, and we will cover that in a later topic. But right now, dealing with structs, this is how we're going to do this. Okay, so we initialize our list. Perfect. All right, so now we want to actually be able to add things to our list. So let's go ahead and create a new function. We will call this void list push. It will take in a list pointer, and it will take the value that you want to add to your list. So what this is going to do, shift over to the whiteboard, is it's going to take in this list. And so what we've done with initialized list, so let's write our type down here. So we have this list. All right, so list is declared on the stack, and list is made up of one member called head, which is a node pointer. Well, head points to nothing right now. It points to null or to 0. Same thing. So on our push, what this push method is going to do is going to walk the list and add the item that we're passing in, the value that we're passing in, to the end of the list. So the first thing we need to do is we need to check to see if head is null. If head is null, then we need to create a new node to store the data in our list. Okay, so we know how to do that. So the first thing we want to do is check to see if list is null. If it is, we're done. Okay, now what we want to do is if list head equals null, then we are going to create our new list. So list head equals new node. We can just do this way. New node. Then we know that we want to assign our new node's next value to null. And we want to assign the head value equal to the value that we're getting passed in. Alright, so let's jump over here and see what we're doing. So the very first time that we do this, list.head is pointing to null. Alright, it's pointing to null. So what we need to do is we need to assign a new node pointer to this. So when we call the new node, that creates a new block of memory. Well, that allocates a new block of memory for us. That's our node structure. And remember, our node structure is made up of the value and the next pointer. Alright, so whatever our value is that gets passed in goes here, and then we're going to assign our next pointer to null. And then we're going to assign our head to now point to here instead. Okay, and that's what our code is doing. We assign our head pointer a new node value. We assign our next null and our value to 0. I go ahead and build this. New types may not be defined. You see, I forgot to put my semicolon at the end of my structure. And this is the kind of weird value, or weird message you're going to get. It's not really clear from this that you forgot your semicolon at the end of the list. It says new types may not be defined on a return type. And that's because we forgot our semicolon. So if we put our semicolon, then rebuild, all is happy. Okay. So now if we call list push down here in our main function, oops, and we want to push a value to list, let's push 1. Okay. So now you'll notice one thing here. We are dynamically creating memory. And since we are dynamically creating memory, we always need to make sure we clean that up. So let's go ahead and create the cleanup method. So we have a list init, we have a list push, and now let's go ahead and add a list, we'll just call it cleanup. And it's going to take in, a list pointer. Okay. We'll do our standard if list equals null check, return. Okay, so let's go ahead and jump over to the whiteboard real fast and let's draw out what we're going to do here. Okay, so in our cleanup method, we have a list. And our list has this head pointer. Well, the list can be in basically 3 different states, or 3 different basic states. It can be empty, you can have a single item, and it could have multiple items. Now we could write an implementation that actually cares about all three of these different conditions, or we can write one that just handles all of them in one loop. And that's what we're going to do. But let's look conceptually what we're going to do. The first state, if the list is empty, that means head is null, and so that means we're just going to exit immediately. So we don't have to do any work. There's no memory to clean up. If there's a single item, our list is going to look like this. We'll have a node. It'll have some value here. Let's just call it x. And it will have the next pointer being null. And so we just need to delete this block of memory. If we have multiple items, well, our next pointer is not null. It actually points to this node over here. We'll call the value y. It points to there. And let's say that there's one more. We'll call that z. And we'll have that one be null. And this one points there. Okay, so what we need to do is we need to walk through and delete each one of these. Well, in order to do that, we're going to need to create a pointer that points to this, and we're going to call this current. And we need to hold on to this next variable. And we will do that in a variable called next. Now, the reason why we need to do this is that when we go to delete this block of memory, as soon as we call delete on this memory address, this whole block is no longer safe to access data from. So what that means is that we need to have already stored the address that's inside this block that points to our next item. Otherwise, we will delete this block and we will have all of these guys over here be dangling around and hanging out in memory, and we don't want that. So we're going to need this temporary variable next. Okay, so let's go ahead and jump over to our coder and code this up. Some extra space there. Okay, so what we're going to need is a node current, and that node is going to point to the first item. Now we want to handle the empty case, so we can do that. We'll do a while loop, and we'll say while current does not equal null, go ahead and start doing some work. And so this is where our empty list is going to be handled for free. Perfect. Now we need a node pointer next that's going to hold current next so that we can delete the node that's being pointed to by the current pointer without having to access memory that's no longer ours. So then we can delete current, and now we need to do the next vital piece that I didn't actually whiteboard here. Now that we've deleted current, this block is free. We need to update current to now be equal to next. So that's easy enough to do. We just set current equal to next. And so now this is actually going to handle the case where we have one item or we have 30 items in there. And the reason is that our next pointer will be null when we're dealing with the last item in the list. So that will happen just automatically for us. Okay, so now that we've actually created a method to clean up our list, let's make sure we actually call it. So right down here we'll call list cleanup, and we'll pass in the pointer to our list. Okay, let's build it. Perfect. Okay, so now we can add items to an empty list. We can clean up our list. We can initialize a list. Let's go ahead and re-implement our print list and finish our push. So we'll actually finish our push first. Okay, so our push did this. It created our first node for us, assigned some value x here, and set that pointer to null when the list was empty. This is when it was empty. Okay, now when we actually have an item in it, what we need to do is we need to traverse the list. So we need to go down our list. Let's say our list has some items in it. This has 1, we'll have 2 here. We need to continue to go until next equals null. Alright, so we're basically going to write a similar loop that we had here. So we need to make sure that we have a current pointer, again, because we're going to need to track this place in memory. And then we're going to need to stop when current next equals null. Okay. And our push. We'll do else. So if our head is null, then we do this. If it's not null, then we need node current, and we will set that to list equals head. And now, instead of our head pointer being null, what we actually want to do is to continue down the list until our current next equals null. So while current next equals null, oops, does not equal null, we will set current equal to current next. Okay, now once we get to current, that is going to get us this pointer right here. So current next, so let's just walk through this list. So if this is our list, okay, list is here. Our current is set to this address. Current next does not equal null. So our next time through the loop, current is going to be here. Current next is going to evaluate to null, or it's going to evaluate, current next is going to evaluate, current next equals null is going to evaluate to true. Our loop is going to stop. Our current pointer will still be right here. And then we can add a new item in this list. So what we want to do is then we do current next equals new node, current next value equals val, and current next equals null. And that's actually it. So you can see we kind of have some duplicated code here. We could clean this up if we wanted to, but I think this will be okay. Let's go ahead and build and make sure we didn't make any syntactical errors at least. Alright, so now we have our print list. Well, our print list used to take in a node. Well, we don't really want that anymore. What we want to do is take in a list pointer. Oops. A list pointer. Okay. Now our return null. Perfect. Let's go ahead and set node next list equal to list head. While next does not equal null, next is next. All of that still looks fine. Okay, so now we've pushed 1. Let's go ahead and push another value, 2, and let's do a third. And now let's print our list. I'm actually going to rename this to list underscore print, just to keep with the naming convention that I've been going with on our other methods. Okay, so now we'll call it list print, pass in the address of our list type, build, everything succeeded. Let's bring up our output window and run it. And you'll see that we in fact have 1, 2, and 3. And we got no crashes, so it looks like we did everything correctly. Alright, so that is going to wrap it up for this video. In our next video, we'll take a look at 2 more actions that we're gonna want to do. We're gonna at least want to be able to delete an item, and then we'll talk about how we could insert items in the beginning of the list if we wanted to. All right, with that, thanks.